Okay, um, this section we're going to talk about functions. The concept of function is central to all of the mathematics and particularly to algebra. So we want students to define and evaluate and compare the functions, and students should be able to model the relationship between the quantities in the function. Okay. So you might have seen this function machine a lot of times, right? So function is like this. You put in something and there is a rule. So we have something like f of x is equal to, so function, this function is 2x plus 1, something like that. Then what's the outcome? So you are given the rule and you are plug in a certain number and you see the outcome, right? So that is kind of brief summary for the function, I will say. So there is an input and there is an output, okay? And there is a certain relationship, which is the rule, which is the function that we are talking about, okay? Here are some examples for you to find the rule, okay? So a teacher gave the input and output here. Students gave the input and teachers gave the output with a certain rule. And you need to find what the teacher's rule is for the following responses. Of course, there are many possible answers, and I'm giving you just a few examples here, okay? So examine that. For 1, the teacher answered 1 becomes 3 with this certain rule. 0 becomes 0, 4 becomes 12, 10 becomes 30. What is the rule? What do you notice? Yes, the teacher's rule should be whatever the student's income times 3. So the income here is given here as the student's response, and then teacher's rule is the function. I say times 3, then 1 times 3 is the outcome, that 3, right? So these are the outcomes, income and outcome, and there's a rule that is hidden. That is what you're looking for here. And our rule for this example is times 3. So 1 times 3 is 3, 0 times 3 is 0, 4 times 3 is 12, 10 times 3 is 30. How about this one? What kind of rule do you see here? The teacher's rule I examine here can be double the original number. So I get 2 times 2 is 4, but I need to add 1 more to get 5, right? How about this? 3 times 2 is 6, 1 more to that is 7. 5 times 2 plus 1, 11. 10 times 2, 20, plus 1, 21. So we can see the pattern here, right? So it's 2n plus 1. 2 times the student's answer plus 1 is the teacher's answer. How about here? What do you see? The answers are only zeros and ones. So I'm going to examine what the student's input was. So for 2 and 4, you get 0. 7 and 21, you get 1. What could be the rule? There should be a lot of different answers, but my rule, I guess, is if the number is even number, the output is 0. If the input is odd number, the output is 1. Right? That can be 1. Or maybe some of you can say, these numbers are less than 7. So if the number is less than 7, then the output should be 0. If it is greater than or equal to 7, the output could be 1. So things like that, you can guess the rule, the function for by examining the inputs and outputs, right? Okay. Functions can be written as equations, like f of x is equal to x plus 3. So for this function, if I use the function machine, I put x in there, and my output is always added by 3 to that input number. So that is my function rule, right? So if I use the table, I can have all the x's here and the y value, the output is here. So input and output. Output is depending on what input is, right? So we call this input as independent variable because you can plug in any number. But for output, it depends on what you put in, right? So it is dependent variable. Okay, so for example, if you plug in 0 to it, so put in 0 in this machine, 0 plus 3, you get 3, that's the output. Plug in 1, so put in 1 here, add by 3, and you get 4, that's the output. Put in 3, add by 3, 6, that is the output, and so on and so on. So it kind of makes sense, right? The definition of a function is this. A function from set A to set B is correspondence from A to B. It's correspondence. So 0 to 3, 1 to 4, 3 to 6, 4 to 7, 6 to 9, and so on. There's a correspondence in which each element of A is paired with one and only one element in B. And we call these x values as a domain and this part as codomain. Okay? Here is an example. A bicycle manufacturer incurs a daily fixed cost of $1,400 for overhead expenses and a cost of $500 per bike manufactured. So there's a fixed cost of $1,400. No matter how many bicycles you're fixing, there's a cost of $1,400. But if you fix another bike, you need to pay $500, 2 bikes, 500 times 2, 3 bikes, 500 times 3, more on top of $1,400. So what could be the cost of manufacturing X many bicycles in a day? So we are finding the function for that. Let me actually copy this question down and work on the Jamboard here. Okay, so let's talk about this together. Okay, so cost of manufacturing the bicycle. So that is the number of a bicycle, right? Where X is number of bicycle. There is a fixed cost. $1,400 is no matter how many bicycles you are manufacturing, you need to pay for that, right? And also, depending on how many bicycles, you need to pay $500. That's another cost. It depending on number of bicycle, which is X. So if X is 1, 500 times 1, only $500 is added to the fixed cost. And if you have 2 bicycles to manufacture, 500 times 2 will be added, and so on and so on and so on. So this is independent variable, right? It's a domain. Okay, that's part A. B. If the manufacturer sells each bike for $700 and the profit or loss in producing and selling X many bicycles in one day, P of X, so that is a profit depending on number of bicycle, right? If you sell more bicycle, you're gonna get more money. So that is P of X. So the profit will be, it depending on how many bicycle you are selling, right? So how much you are making by just selling the base bicycle? 700 times X, right? So if you sell only one bicycle, you're gonna make $700. If you make 2 bicycles, if you sell 2 bicycles, 700 times 2, 10 bicycles, 700 times 10. So that is how much you are making, but that is not your profit, because the profit should be the margin that you are making, right? By taking away the cost, C of X. So how can we rewrite that? it will be 700x minus cost is 1400 plus 500x. Don't forget that you're taking away the whole thing. So in the parentheses, 1400 plus 500x. So 700x minus each of these values, 1400 minus 500. That is where the distributable property occurs. Okay. So now we have x term here and x term there, so we can combine them together. So 700x minus 500x will be 200x, and we still have minus 1400. That is profit function that you can find. Now we can apply part C. It says we need to find the number of bikes and find the break-even points. Break-even points is when your profit is 0. So the cost should be same as how much money you are making, the revenue, right? So we can say when P of x 200x minus 1400 is 0, it is break even. You're not making money, you're not losing money. Okay, so how do we solve it? We want to solve for x, the number of a bicycle, but it is subtracted by 1400, so we can add 1400 on both sides. So minus 1400 plus 1400 is 0, and you still have 200x. On the right hand side, 0 plus 1400, 1400, divide both sides by 200, 200, then 200 divided by 200 is 1, 1 times x is x. And here I'm going to divide numerator and denominator by 0 first, and then divide both by 2. So I have 7. So if you sell 7 bicycle, use the context again, okay? If you sell 7 bicycle, your profit will be 0. So to make bigger profit, you need to sell more than 7 bicycles. Does it make sense? Okay, functions can be used as arrow diagrams, and the arrow diagrams determines whether this is a function or not. Before we jump into this problem, I want to talk about this arrow diagram a little bit and the function. So think about function as a birthday. So let's suppose we have students here in X. So student A, student B, student C, and student D. And they have their birthdays here, right? So let's say birthday month. So we have January, February, March, April, May, and so on and so on and so on. Let's actually write more and more. June and July, August, September, October, November, December. All of these are in this Y value. So there's a one-to-one correspondence there. And let's have A's birthday month is February, and student B's birthday is in June, and student C's birthday can be also February, right? And D's birthday, let's say it's December. So function is like this. Every number in the domain has to have corresponding number in the codomain. Every number has to have, right? Like everybody has a birthday. However, not every birthday month can be applied. So there's no correspondence for every numbers here in the codomain, right? And also you can have more than one for one element in the codomain, just like a birthday. Okay? So function is like this. Every element in the domain has to have correspondence in the codomain. The codomain doesn't have to. Okay, so knowing that, let's examine this arrow diagrams. Let's take a look at this. So you can see the arrow starting from here, which means this is domain, and going here, so it's a codomain. You see the arrows? So starting arrow points are the domains, and the other part is a codomain. Just like a birthday, you need to use all of these domain elements in the domain. They need to have one and only one correspondence. But for this one, you see, person 1 cannot have 2 birthdays, right? Can have only one birthday. So no, this is not a function. How about this one? B does not have a birthday. It should have a birthday too, right? It does not have a correspondence there, so it is not a function. Part C, X has correspondence, Y has correspondence, Z has a correspondence. All of these elements in the domain has a correspondence, right? So it is a function. How about part D? Every element in the domain has correspondence. Just like birthday, you can have more than one in the codomain, right? So yes, it is also a function. And of course, this is a function. Okay? So hopefully that makes sense. Okay, and here is a word problem. Jonah is shipping 5 boxes for his uncle. Each box is the same size but a different weight. You see the different weights? The cost to ship each box is shown here. Okay. Should Jonah expect that the cost to ship a 15-pound box will be a unique cost? Which means we are finding the specific relationship between the weight and the cost. So let's find the rule for this. Step 1, you can organize the data using ordered pair. So if you are not familiar with ordered pair, you can think back to middle school and high school. Say that in the parentheses you put x value first, comma, and y value. That is ordered pair. So you put input first, then outcome using a certain rule. So if I use the pounds, the weight as input, because the cost will be depending on how much the parcel weigh, right? So the weight will be independent variable, and the cost will be depending variable because the cost is depending on the weight. Then we can put these numbers. For 9 pounds, it is $8.72. For 8 pounds, it's 8.56. For 10 pounds, $9.01. 12 pounds, $9.55. 14 pounds for $10.03. Right? And these ordered pairs, we don't know whether it is a function or not yet because we didn't find the rule. But there is some kind of relationship, right? So we just say that these pairs is a relation. A relation can be function if all of this item has correspondence there and we use a certain rule there, right? So using arrow diagram, we can match each of them. So it is a function when each input is assigned exactly one output, right? So this relation is a function. So Jonah can expect that the cost for 15 pounds box, and there will be a certain outcome for that. We can also use functions as tables, not only order the pairs, right? So here is a table. So we can put input here and output there. This table is shown amount of advertising in $1,000. So for no dollar advertisement, you have no sale. On the one sale, no, sales, amount of sales in $1,000. So only one item is sold. If you pay $1,000, you sell three. So it's kind of related, right? You can see the relationship there. So you can use the tables like that, input column and output column. We can put these as ordered pair, like 0, 1, 1, 3, 2, 5, 3, 7, 4, 9, all in the parentheses. So let's look at some examples here. Which of the following sets of ordered pairs represent functions? If a set represents a function, give its domain and range. So domain, is the input and range is the output, okay? So let's look at the first one here. Do you think this is a function or not? If it doesn't come to you right away, you can also draw the arrow model too. But as you can see, for input of 1, you have two different values. It's like one person. So student number 1 has 2 birthdays. It doesn't make sense. It cannot be. So it is not a function. How about this one? We have all different x values, right? Elements in the domain. So everybody has certain number. It can be repeated, but every number in the domain has ordered pair. So it is a function. How about C? So we have 1, 2, 3, 4. Each one has certain values. It can be repeated because student 1, 2, 3 can have same birthday, right? So it is a function. What does this mean? So if you think back as a set notation, there is a set with ordered pair A, B, where A is a natural number and B is 2 times that number A. So it already gives you the rule, right? So A is the domain, and B, 2A, that is the range. Okay. Oh, did I say the domains and range for this? So domains here is x values. It's not even a function, so we're not gonna take a look at that, right? But this one is the function, and with the domain 1, 2, 3, 4, range 1/2, 1/3, 1/4, and 1/5. For this one, the domains are the x values 1, 2, 3, 4, and the range 0 and 4. And for the last one, it is also a function with a domain natural number, because A is all natural number. So all natural number and range is a set of all even number, because it's 2 times of any number. 2 times any number is even number, right? Okay. We can also represent functions as graphs. Okay, so you might have seen the graphs like linear function. So if you have only x term and the constant can be 0, then you're going to have a straight line, so it's a linear. If you have degree 2, so x squared, like f of x is equal to ax squared plus bx plus c, you're going to have a quadratic function, so you're going to have a curve. You don't have to go deeper than this, but just for brief review, if your function is odd number of degree function, so for example f of x is a times x, a can be any number, not 0, or ax cubed plus bx squared plus dot dot dot, and ax to the 5th plus bx to the 4th plus dot dot dot, ax to the 7th. Do you know what I write here? You see that? So I'm talking about the leading degree is odd number. Leading term is odd degree. then the graph will be similar to the linear. So for a, f of x is equal to ax plus b. So if x has 1 degree, it's going to be straight line like that or like that or like that, or straight, parallel, or horizontally or vertically, any straight line. From a to the x to the cube, fifths and sevenths, very similar, but has a little bit of a curve. If a is positive, it goes increasing. If it's negative, decreasing. So it seems like this kind of graph. If your function is even degree, like x squared plus something dot dot dot, or x to the fourth dot dot dot, or x to the sixth dot dot dot, these graph has curves. If a is positive, the curve looks like this, so downward, and if a is negative, the curve is like that. You have maximum there. So okay, very similar shapes for any even degrees there. Okay, so that is the functions and the graph. And we can also talk about the sequences as a function. So consider finding the sum of all natural numbers from 1 to 100. Is there any way that you can find the sum of the natural number easily? So let's consider that together. So what I'm looking for here is sum of 1 plus 2 plus 3 plus all the way to 100. Right, so I'm going to write a little bit more, 97, 98, 99, and 100. We are adding all of this together. So if we say that is a sum of all the way to 100, sum of all natural numbers from 1 to 100, then I can rewrite this backwards, like 100 plus 99 plus 98 plus dot 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 dot, backwards, 1, 2, 3, 4. Right? It's still sum of all natural numbers 100. Right? If I add these two together, what happens? I have two sums of 100, and 1 plus 100 is 101, 2 plus 99 is 101, 3 plus 98 is also 101. All of these sums in that column will be 101. Right? How many are there? I have all the way from 1 to 100. There are 100 many of them. Right? So 100 plus 100 plus 100 plus 100 plus 101, 100 times of that is 100 times 101 is 2 times sum of all natural numbers up to 100. Then I can find sum of 100 by dividing both sides by 2. So divided by 2. If I simplify this, I can have this will be divided by 2 times 101. So what's 101 times 50? I have answer for that. Okay, let me use the calculator. 101 times 50 is 50. So the sum of all natural numbers from 1 to 100 is 50. Here we can deduce a rule. So S of n, the sum of any number all the way to n, whatever n is, n can be 50, n can be 1000, n can be 100, and so on and so on. I can rewrite this backwards. N, what's 1 less than n? N minus 1. What's 1 less than n minus 1? N minus 2, and so on, all the way to n. So if I add each column together, I have 2 times sum of the number, and I have 1 plus n, or n plus 1, right? And if you add n minus 1 plus 2, 2 minus 1 is 1, so it is still n plus 1. So I have n plus 1 all the way here. And how many are there? 1, 2, 3, 4, 5, 6, all the way to n. So there are n many of them, right? Then I can rewrite this as n times n plus 1 is 2 times the sum. So the sum should be, we can divide both by 2, right? So n times n plus 1 divided by 2. So you can come up to the rule, okay? So here is, similarly, you can find a more generalized form for the sum. So if you have a sequence like first number, and you are adding d to the first number to get the second number. So I'm adding d to that for the second number. So this is the first number, this is the second, and the third number will be just d more to this, right? So add d to this, then we will have a sub 1 plus 2d, because you already have 1d and I have add another d. So 2d, and the fourth number will be a sub 1 plus 3d, and so on and so on, right? Then think about what could be the nth number and examine the pattern. What is fixed? A sub 1. A sub 1 is fixed. So I know that nth number will have a sub 1 and plus something d, right? Something d is added. So I'm going to examine that and see that, oh, this is 1d, this is 1d, this is 2d, this is 3d. Compare that with the number of sequence here. Second number is 1d, third number is 2d, fourth number is 3d, and first number is 0d, because 0 times d is 0. 0 plus a sub 1 is a sub 1. That's why it is not written. But we can write that as 0d is added, right? Because it's still a sub 1. Right? So we can see that, oh, this number that is multiplied by d is always 1 less than n. So n minus 1 times d is multiplied. So that is the nth term. So I can say that the nth term will be a sub 1 plus n minus 1 times d. That's the nth term. So I can rewrite this backwards, right? So I can rewrite this a sub n there, starting from a sub n, which is this. This is the same as a sub n. And previous one should be d less than a sub n, right? So previous number is always d less than the next number. So going backwards, we can just subtract d from the previous number. So a sub n minus d, and the next one will be a sub n minus 2d, because I'm subtracting d from this number, and so on and so on and so on. So the last one will be a sub n, no, a sub 1, right? The going backwards, the last number is a sub n. So if I add these two together, let's see what's happening. So I have 2 s sub n, and I have a sub 1 plus a sub n for the first sum. And here I can get rid of that, and I have a sub 1 plus a sub n all the way to here. So a sub 1 plus a sub n. So I have 2 times s sub n is equal to that, and of course you can see all of these are the same number. So repeated addition can be rewritten as multiplication, right? So I have a sub 1 plus a sub n. How many times? How many of those? All the way from 1 to nth term, right? So there are n many of that. And on the left hand side, it was 2 times a sub n, because I added a sub n. Now I can divide both by 2 to find the sum. So cancel that out, and s sub n is n times a sub 1 plus a sub n divided by 2, right? So that is how we find the sum. And that is the theorem. Oops, where is it? Here. S sub n is equal to n times a sub 1 plus a sub n divided by 2, right? Okay. So you can write this down on your notebook. The arithmetic sequence, which means you are adding the same number to the previous number to get the next number with that same rule, where first term is given and nth term is given, you can add those two terms. So first term and the last term divided by 2, whole thing times number of term. Okay, so here is one example. Find the sum of the first 100 terms of the following arithmetic sequence. So we are given arithmetic sequence. What is arithmetic sequence? It is when you are adding the same number continuously. So let's examine this together. Alright, so from 3 to 7, you added 3 by 4, and you add 7 by 4 to get 11, and add by 4 to get 15, add 15 by 4 to get 19, and so on and so on. So you see that we are adding 4 constantly. So our D is 4, and the first term is 3. That's the first term, right? And it is arithmetic sequence because we are adding same number, which is 4 in this case. Now it says you need to find the sum. So the sum of arithmetic sequence for nth term, what is the formula that we found? Is n times the first number plus last number divided by 2. Remember that? So how many numbers are there? Well, it says first 100 terms. So we are having first term through 100th term, and our n should be 100 then, right? So we have 100 times first number 3 and 100th number 8th of 100 over 2. Okay, but how do I find the last number? That is my question. So ace of n, to find the ace of n, oh, I need to talk about that too, right? In arithmetic sequence. So let's go back to the arithmetic sequence. Okay, so let's suppose you have arithmetic sequence again, a sub 1 plus d. So we are adding d to the previous term, and the third term should be a sub 1 plus 2d because we are adding d to the previous one. We'll keep adding d. So a sub 1 plus 3d, and so on and so on and so on. Then for the nth term, we will have a sub 1 plus n minus 1 times d. Remember? So we already talked about that. So nth term is a sub 1 plus n minus 1 times d. Then what is 100th term? The first term, which is 3 plus n is 100. 100 minus 1 is 99. And what's the difference? The number that we are adding continuously is 4. So if you do 3 plus 99 times 4, we multiply first before you add. So if you use your calculator, or you calculate multiplication first and then add by 3, you get 2100. So the last number here is 2100, right? And you multiply this by 100. 100 times the whole thing is the same as 100 in the numerator. So because it's 100 over 1, okay, it's the same thing. It doesn't matter. So you can find the sum. Oh, I did the wrong one. So what is this number? 99 times 4 plus 3 is 399. Okay, so let me rewrite that. So we have 100 times 3, first number, excuse me, and last number 399 over 2 is 100 times 3 plus 399, 402 over 2 I want to keep 100 and simplify it with this. So 201 times 100, it is 20,100. So that is the sum of the first 100 terms. So all the way from 3 to 399 in this arithmetic sequence. Now consider geometric sequence. So the difference between arithmetic sequence and geometric sequence is whether you are adding the same number or you multiply by same number. So arithmetic sequence, you are adding the same number over and over again, right? For geometric sequence, you are multiplying same number to the previous number to get the second number. What I mean by that is this. So you have a sequence starting from first number. Second number, you are multiplying by a number. Let's say that's an R for this case, to get the second number. To get third number, you are multiplying this by R. So a sub 1 times R times R times R is R squared, right? And the next number, the fourth number, you multiply this by R. So you have a sub 1 times R squared times R, which is R times R times R, R to the cube, and so on and so on. So you can see the pattern here. What do you notice? The first number is multiplied by R to the 0th power, because that is 1, and 1 times a sub 1 times whatever number is itself, right? And this is 1 hidden here. So you can see that it is a sequence of a sub 1 times R to the 0 power, a sub 1 times R to the 1 power, a sub 1 times R squared, a sub 1 times R cubed, and so on and so on and so on. And this is the first number, this is the second term, and this is the third term, and this is the fourth term, and so on and so on, right? Oh, where's R? R to the third power, and so on and so on. So you kind of see this pattern here, right? So we can examine what is fixed. A sub 1 is fixed. So we know that the nth term will be a sub 1 times something, R to the what? That is changing, right? So compare that with the number of terms. For the first term, you have 0th power, second term, 1 power, third term, second power, fourth term, third power. So it is always 1 less than the number of terms. We can see that the nth term will be R to the n minus 1, right? So in geometric sequence, when you are multiplying the number to get the next number, we can find a sub n should be a sub 1, the first term, times R, the number that is multiplied constantly, to the n minus 1 term. Okay, so that is a geometric sequence. So you can see the nth term, where's my cursor? Nth term is a sub 1 times R to the n minus 1 power. Using this, can we find the sum? Of course we can, right? So let me rewrite that for you. S of n, the sum, all the way from the first term to the nth term, can be rewritten as first term plus second term, a sub 1 times R, plus the third term, you multiply that by R, so R squared, and so on and so on and so on, all the way to the nth term, which is a sub 1 times R to the n minus 1 term. If I multiply this whole thing by R, and I will write that above this, so R times n, so I'm multiplying this whole thing by R. What do I get? A sub 1 times R, so I'm going to start from here, a sub 1 times R, and multiply this by a sub R, then you have a sub 1 R squared, and so on and so on and so on. So I'm kind of pushing everything, to the right. So one term before nth term will be a sub 1 times r to the n minus 1 term, and the last term you multiply this by r, then you're gonna get a sub 1 to the r to the nth power. That is when you're multiplying r to this sum. Now what do you notice? We can kind of cancel this out if we subtract this yellow part s of n from r times s of n, right? So that's what I'm going to do. If you subtract this whole thing, what do I get on the left hand side of the equation? I have r times Sn minus 1 Sn, and S of n is common, so we can factor that out and we have r minus 1, right? And here 0 minus a sub 1, so I have negative a sub 1 there, and this will be cancelled, and I have plus a sub 1 times r to the n power. Now examine these two terms. I see the a sub 1 is a common factor, right? So I'm going to factor that out, but first I want to switch these two around using the commutative property in addition, because I like to have positive number at the beginning, but it doesn't matter, but this is the same thing, right? Okay, now I see that a sub 1 is a common factor, so factor that out. And what do I have? A sub 1 times r to the n makes this, and to get negative a sub 1, I can multiply minus 1 by a sub 1. So I can factor a sub 1 and multiply that by r to the nth power minus 1. That is left hand side, r minus 1 to the s of n. So what is s of n? I can divide both by r minus 1, right? R minus 1 and a sub 1 times r to the n minus 1. And again, this is the same as a sub 1 times r to the n minus 1 over r minus 1. So I can say that a sub 1 over 1 is the same as a sub 1. So you can factor that out, okay? It's the same thing. And that is the rule for geometric sequence sum. Okay, here is the steps. So a sub 1, the sum of all the numbers from first term to n terms, you can have this formula. Okay, of course, if you have any question, you can answer that too using this formula. So for example, I will give you just one example. If you have a number like, let's make geometric sequence. So times 2 all the time. 3 times 2 is 6. Times 2, 12. You multiply this by 2, 24. This is the sequence. And there are 100 numbers. So let's figure out the nth term. How do you find the nth term? Nth term is the first number, a sub 1, times r to the n minus 1, right? So for 100th term, then will be the first number times what is r. The rate is 2 to the 100 minus 1, which is 99. So that is my last number, right? So you can find that. And how do we find the sum s of n in this geometric sequence will be is 100, because I'm adding 100 terms, right? Is first number a sub 1 times r to the n minus 1 over r minus 1. So the first number is 3. R to the, my n is 100 now. R to the 100th, what is my r? It's 2, right? That is r. So 2 to the 100 minus 1 over 2 minus 1. Now you can just use your calculator to find this answer. Okay, so what's 2 to the 100th number? Let's see. 2 to the 100th is, big number. Oopsie. So this is the same as 3 times 2 minus 1 is 1, so over 1 you can just keep that. I will just keep that as 2 to the 100th minus 1. Okay, so you can have 3 times 2 to the 100th minus 1, or 3 times 2 to the 100th minus 3. Either way, it's the same because you can distribute 3 to each of these terms. Okay, so that's for section 3. Thank you, everyone.